Welcome to a brand new section, Database Operations. This section will teach you how to integrate Python with a powerful external database system to store data. 1. Why databases? Files are great for small amounts of data, but a database management system like MySql offers speed, reliability, and structured organization for large, complex data. It is the core component for everything from web applications to accounting software. 2. Introducing MySql. MySql is one of the world's most popular open-source relational database management systems, or RDBMS. It stores data in structured tables with defined relationships, ensuring data integrity. It uses the language SQL, or structured query language, to manage and manipulate that data. 3. The CRUD operations. All database operations can be broken down into 4 essential functions, commonly known as CRUD: create, read, update, and delete. In this section, we will cover how to perform the most important operations, namely read, create, and delete, using Python code interacting with a MySql database. 4. Section Roadmap. This section will guide you from setup to execution. We start by installing the MySql server and its graphical client, MySql workbench. Then we install the Python connector, set up a database, and perform all the core operations covering read, create, and delete. To summarize, we are ready to begin integrating Python with the world of databases. The first step is getting the MySql server installed on your system. Our next lecture 28.02. Install MySql. See you there. Welcome back. Our journey into database operations begins with installing the engine that powers it all, the MySql server. This is the software that runs in the background to store, retrieve, and manage your data. 1. Downloading the installer. First, access this web page. Two. Setting the root password. Next, you must set the password for the root user. The root user is the super administrator of your MySql server. Choose a secure password and write it down. We will need this password later to connect our Python script to the database. To summarize, your MySql server is now running. However, managing it via the command line is difficult. In the next lecture, we install a friendly graphical tool for managing our database, MySql Workbench. Our next lecture 28.03, Install MySql Workbench. See you there. Welcome back. While the MySql server is the engine, we need a friendly tool to interact with it. That tool is MySql Workbench. This is a graphical interface that makes running SQL queries, creating tables, and viewing data much easier. 1. Installing Workbench. First, you access this page. Two. Launching Workbench and connecting. Once installed, launch MySql Workbench. Here, I see an entry under MySql connections. Its name is Local Instance 3306. This connection is pre-configured to point to the server you just installed. Click this connection. 3. Root password. When you click the connection, a window will pop up asking for the password for the root user. Enter the root password that you set during the MySql server installation. Four. The workbench interface. Once connected, the main SQL editor will open. This is where we will write our SQL commands. You will see a panel on the left that lists all the schemas, which is the MySql term for databases. To summarize, we have the server and the graphical client ready. Our next lecture 28.04. Install MySql connector. See you there. Welcome back. We have the MySql server running and the Workbench GUI installed. The final setup piece is the MySql connector. This is the specialized Python library that allows our code to talk directly to the database server. 1. Using pip3 to install the connector. This step is simple. Open your terminal and use pip3, our package installer, to get the connector library. The package name is MySql-connector-python. 2. Installation command. Type the command pip3 install MySql-connector-python. After running this, pip3 will download the library and install it into your Python environment. 3. Verifying the installation in Python. To quickly check that the library is correctly installed, try to import the module. Import mysql.connector. If the command runs without an error and prints the success message, you are ready to proceed to the next step. To summarize, we are fully equipped now. Server, GUI client, and Python connector. Our next lecture 28.05. Set up the database. See you there. Welcome back. The MySql ecosystem is complete. Now we use MySql Workbench to create the structured environment our Python script will interact with. We need to define a database and a table to hold our data. 1. Creating the database. Open MySql Workbench and connect to your local instance. A database is essentially a container for tables. In the SQL editor, we run the command to create our new database, which we will name PythonDB. After running this SQL command, refresh the Schemas panel on the left, and you should see the new database appear. Now, we must tell MySql that all subsequent commands should be executed within this database using the used command. Two, creating the users table. Within the Python DB database, we create a table named users to store records. Every table needs columns with defined data types. Our table will have 4 columns: ID, name, email, and age. The ID column is set as primary key and auto_increment, meaning MySql automatically manages a unique identifier for each user. Varchar is a common type for variable length strings, and int is for integers. Not null ensures a value must always be provided for that column. To summarize, the database is set up and ready to hold our data. Our next lecture 28.06. Connect to the DB from Python. See you there. Welcome back. The database is structured, the server is running, and the connector is installed. This lecture is about making the crucial link, establishing a persistent connection from our Python script to the MySql database. 1. Importing and defining credentials. We import MySql.connector. We then define the necessary connection variables. The host is localhost since the server is on our own machine. The user is the MySql root user. You must replace the password with the secure root password you set during the MySql installation. Finally, we specify the database we created in the last lecture, PythonDB. 2. Establishing the connection. We wrap the connection attempt in a try except block to catch potential errors, like wrong passwords or a server not running. We call mysql.connector.connect parenthesis, passing our defined variables as keyword arguments. If successful, this returns the conn object, which is the communication line to the database. We check conn is underscore connected parenthesis to confirm the status. 3. Creating a cursor object. Every operation, whether reading or writing data, requires a cursor. We get the cursor by calling conn.cursor parenthesis. The cursor is the object responsible for executing SQL commands and fetching the results. Finally, always ensure you close the cursor and the connection when your work is done to free up resources. To summarize, we can now talk to MySql. Our next lecture 28.07. Read. See you there. Welcome back. With our database connection established, we start the CRUD operations with read. To read data, we must first ensure there is data to read. We will temporarily insert a test user using MySql workbench, and then fetch that data using Python. 1. Inserting sample data. Switch over to MySql workbench. Run this SQL command to insert one test user into our users table. Notice we skip the ID field because it is auto_increment. 2. Preparing the Python script. Back in Python, after connecting and creating the cursor object, we define our SQL query string. We use select asterisk from users to retrieve all columns from the table. Limit 1 is added to ensure we only get a single row, which is useful for testing. 3. Executing the query and fetching data. First, we use cursor.execute parenthesis to send the SQL query to the database server. Second, we call cursor.fetch1 parenthesis. This method retrieves the next result row from the executed query and returns it as a tuple. If no more rows are available, it returns none. We then print the resulting user_record. To summarize, we successfully executed our first read operation and retrieved a single record. Our next lecture 28.08. Read fetchall. See you there. Welcome back. In the previous lecture, we learned to retrieve a single row using fetch1. But most database operations require fetching an entire result set. This lesson focuses on the fetchall method, which is essential for working with multiple records. 1. Inserting multiple sample records. To ensure our fetchall command works correctly, let us quickly insert a few more records into the users table using MySql workbench. 2. Executing the full select query. Back in Python, we used the select asterisk from users query, this time without the limit 1 clause, to retrieve all available records. The cursor.execute parenthesis command sends this query to the server. 3. Retrieving all results with fetchall parenthesis. The cursor.fetchall parenthesis method retrieves all remaining rows from the query's result set and returns them as a list of tuples. Each tuple in the list represents one row of data. We can then easily iterate through the all_records list to process each user individually. To summarize, you can now read, retrieving single records or entire datasets. Our next lecture 28.09. Create. See you there. Welcome back. We have learned reading data. Now, let's tackle the next essential CRUD operation, create or inserting new records into the database. We will learn how to safely pass Python variables into our SQL query. 1. Defining the insert query with placeholders. The SQL command for insertion is insert into. Crucially, instead of embedding the data directly into the query string, we use placeholders, which are %s symbols in MySql connector. This practice prevents SQL injection attacks, a major security risk. We define the actual values for the new user as a Python tuple, new_user_data. 2. Executing the insert query. When calling cursor.execute parenthesis, we pass the SQL string as the first argument and the Python data tuple new_user_data as the second. The connector securely substitutes the tuple values for the %s placeholders in the SQL query before sending it to the server. 3. Committing the transaction. This is the most critical step for any write operation. Unlike select, which only reads, and insert, update, or delete, command only stages the changes until you explicitly call conn.commit parenthesis. The commit makes the changes permanent in the database. After a successful insert, we can use cursor.lastRowID to retrieve the automatically generated ID of the new record. To summarize, you can now add new data securely. Our next lecture 28.10. Delete. See you there. Welcome back. In our final CRUD operation for this section, we cover delete, or how to remove records from a table. Just like the create operation, this is a write operation that requires the commit command to finalize the change. 1. The delete query structure. The SQL command is delete from followed by the table name. The most important part is the where clause. This clause acts as a filter, specifying exactly which rows should be deleted. If you forget the where clause, the command will delete every single row in the table. 2. Preparing the Python delete script. We use the safe, parameterized query method again. Our SQL string specifies that we want to delete a user where the ID column matches the placeholder %s. We define the target ID as a tuple user_ID_to_delete, even though it contains only one value. The comma after the number 4 is important to ensure Python recognizes it as a tuple. 3. Executing and committing the deletion. We execute the query, passing the ID tuple as the second argument. Once executed, we must call conn.commit parenthesis to permanently remove the record from the database. The cursor.rowCount attribute tells us how many rows were affected by the last executed query, which should be 1 in this case. To summarize, congratulations! You now know how to connect to a MySqL database and perform the fundamental CRUD operations: create, read, and delete. This wraps up our section on MySqL. Our next lecture 29.01. Introduction. See you there.